Pa dobro večer svima. Za sad imamo samo jednog gledalca. Dobro, bit će bolje, valjda, ovako. Dobro večer svima. Ja ću danas samo da najavim naše gosta brzo, ali uradit ću to na engleskom, zato što naš gost priča engleski. Tako da I'm gonna switch right now in English. Hello, Zach. Hello, Zach Jones. How are you?
Hey, Marin. I'm going good. How are you doing?
Oh, perfect. Welcome to our 11th meetup. So this is, we are still practicing our meetups online, but we're hoping that soon we'll be able to do them in person. We are going to see about that. So
Awesome.
Currently we don't have much viewers, so let's wait a few minutes until people come.
Mm-hmm.
So I hope soon we will see a few persons showing up.
Awesome. Yep. Let's wait then.
So where are we? Where are you coming from? Where are you located?
So I'm based in Bangalore, India. So you might have known about the whole Indian community day that's happening tomorrow. That's virtual. And
Okay.
So.
Yeah. So I guess even if it's virtual, basically it's everybody would be able to attend, right?
Yes.
Okay. So can you share the link at the end of the? Yeah. Okay, that would be perfect.
Just getting that.
Mm-hmm. Okay. So what's the time over there?
It's 11:30 in the night. So.
Okay. So party time.
Yep.
Okay, cool. Yeah, sorry we are calling you this late for you, but it is what it is. Sorry about that again, but
No worries.
Okay.
So yeah.
Let's wait a few more minutes. Okay, for some reason I'm getting the viewers and then I'm losing them. I'm not sure if there is something wrong with
the count on StreamYard.
Yeah. Okay, it's funny. Let me just test the connection.
Sure. Yep.
Hopefully it works.
At least it's saying live and past 4 minutes. So yeah.
Mm-hmm.
The connection should be right then. Otherwise, you don't get the live feed happening, right? So.
Sure. No. Yeah. Yeah, it seems it works fine. So.
Awesome. Yeah, let's wait in for a while then.
Yeah. Anyway, this is gonna be recorded, so we're gonna be able to the people will be able to watch it even later. So I'm not worrying about that.
Yep.
Okay. I think we should start. Okay, welcome again, Zach Jones. Thanks for being our guest tonight. Zach Jones is a fellow community builder and he was a speaker on multiple conferences, and he's going to tell us a few things about the step function. So, Zach, be our guest.
Thanks, Maran. So
Sure.
let me share my screen. Yep.
Okay.
Awesome.
Okay.
Awesome. So today, thanks, Marin. We'll be talking about step functions, and it's been about 2 months that I'm still talking about step functions, and I'm super excited. So, Marin, you gave me a good introduction, but just to add on a little more, I'm a senior developer advocate at Freshworks. I'm an AWS community builder. I also co-organize AWS User Group Bengaluru. I come from the serverless background, and I've been in the past where I've taken up roles in the past, which includes designing and solutioning applications with serverless tech stack. So, hello everybody. So, I guess there was somebody telling good evening, so good evening to you too. In case if you want to connect with me, you could use the QR code that's available, and you can connect me on different social media networks. So today, we'll be speaking about step functions. And when we speak about step functions, one thing that comes into mind is state machine and the whole fact about how we could make it as a workflow. So I thought, why not turn the whole agenda itself into a state machine diagram? So you can see from the agenda where we'll be starting off with step functions. We'll look into ASLs, that is Amazon States Language. We'll look into different things, different features of step functions like API actions, SDK integrations, and intrinsic functions. And holistically, we'll be moving into the world of Lambda-less, which includes having your complete workflows on step functions. So yeah. I have been authoring a lot of blogs about step functions with different SDK integrations. All of them are available in the QR code in the screen, so you can scan and reach out to that. So, when you speak about step functions, the first thing, like I was mentioning, that comes into mind is workflows. So, what is step functions? Step functions is nothing but it's a serverless orchestration of workflows where you can design your own workflow with different components. In step function language, it's called as tasks, which can integrate with different services. When I say different services, it's not just different specific services like Lambda functions or only serverless specific functions, serverless specific services, but it can also integrate with a lot of AWS services, nearly 300, or at least around 300 services, where all these integrations happen with SDK based integrations, or it is over optimized HTTP, where it's underlyingly step functions is going to be using the API actions that's available from that specific service and make a HTTP call or a SDK HTTP call so that that whole API action is satisfied or completed and it returns a response back. All these workflows are defined with something that's called as ASLs, which is Amazon States Language, which is a JSON-based definition of your complete workflow. So it defines what are the different resources it's using, what are the parameters that you need to send to that specific task, what's going to be the output, what's the next step. All these definition is available as a single JSON itself. So in case if you're wondering, there's a state machine diagram that I've added in the slide, which talks about invoking a Lambda function, doing a get bucket ACL, where all these are integrated with specific AWS service, and all this definition. What you're seeing is a pictorial representation of the workflow, but all this is available as a JSON file as well, and that is nothing but your ASL based JSON. And when you're trying to integrate with different services, most often we would have to create workflows which has different combination of types, where you want to switch between a case or you want to loop between some objects. All these things are possible with step functions, where you could have different flows, a combination of flows, Into the session, I'll even be walking you through a complete workflow which has multiple of these flows and combined combination of all these flows available. And when you want to design these workflows, often it's hard for developers to define something in a JSON because you have a lot of parameters. And when you are defining these parameters, it's hard to remember, okay, what is a attribute name going to be? Or the key value, what's the key going to be? Like, you can't remember if it's a resource with R caps or R small, right? So when you think of these hassles or difficulties when defining your ASLs, what makes it best is we have a Visual Studio available, Visual Workflow Studio that's available, where you could just drag and drop different services, define your parameters with a whole low-code experience, where you're seeing something from the Visual Code editor that I have taken a screenshot from, where it's integrating with different services, and all of these components, or the rectangle boxes that you see, are all uh, drag and drop components. And you can even define what is the different flows available. And like I was just mentioning, what are the ways, what's the next flow that's going to be there. All these are available as a few clicks or a form fields in the Visual Studio, so you don't have to worry about how do I create the whole JSON structure, because this JSON could be hundreds of lines. In a production level scenario where you have a huge workflow, it could be hundreds of lines, and writing this is hard. So the workflow studio that's available makes it so easy for developers to just create their own workflow on the fly, and even generate the JSON in the end, so that you can just take it and integrate it with their IAC practices. And the best part about this is, when you're integrating with different API actions, some of them could be synchronous calls, some of them could be asynchronous calls. So all of these is supported with different integration patterns that's there in Step Functions. And when you're doing all of these things, you need to pre-process something, or before you send a request, you want to pre-process something, you want to, when you're getting the response back, you want to post-process some data. All of this is possible with intrinsic functions. Into the session, I'll even be talking about what are different intrinsic functions. So just a brief introduction of intrinsic function itself. It's the functions or methods defined in the ASL language, which helps you to pre and post process your data. And of course, when we're speaking about pricing, all of these are based on per state machine transition based pricing for standard workflows, and for express workflows based on the number of executions that's happening. Of course, I'll be going into the types of workflows as well into the session. So yes, coming to this type of workflows I was just mentioning, there are two types of workflows that Step Function provides, and one is standard and the express. What's the beauty of it is, express ones are suited for some low, I wouldn't say low, but still something that has a less frequency of, or less duration for its execution. It's well suited for those kind of workflows where you just have a couple of services integrated, the workflow completes, and the whole execution is done in a couple of minutes. I mean, the max you could do it with Express is 5 minutes, but with a standard, the workflow could run for a year. So in case if you have something like it should run a ECS task and you should wait until the ECS task is completed, it could take until 1 year for maximum that you complete the task and then proceed ahead to complete the whole execution. And when you're trying to work with different state transitions, standard state machines or standard workflows allows about 4,000 plus transitions, and whereas Express is unlimited. So I was just mentioning you about pricing. So standard has a per state transition. So even if you do a lot of states, you could go to the max of 4,000. But whereas with Express, you could have multiple transitions, and all of these are priced based on the number of executions and the duration and the memory that it used for the whole duration, whole execution of the state machine. Of course, one drawback that we could see about Express is there's a possibility of the whole state machine executing multiple times. So the promise or the fact that we would have to keep in mind is that express workflows execution happens at least once. That means there could be multiple such scenarios that could happen. But with a standard workflow, it's a hard rule that it only executes once, so you don't have to worry about all the error handling that you would have to do. Say, for example, you're working with a user sign up process, and if it's express, there is a chance that the whole execution can repeat, and that might create issues like duplicate users and all those things. But with standard workflows, that is not there, and you could easily create your own workflow and ensure that the whole execution can happen only once.
So that means that with Express, you need to make your function, whatever you're using to integrate with step functions, it needs to be independent, right? In order to not to be able to repeat the same thing once more and then um, uh, basically create some issue out of attempting 2 times to execute the same thing.
Right. You need to have some conditions and queries in place which can validate the execution if it's for the first time.
Sorry, I interrupted.
No worries. It's good to interrupt.
Okay.
So, like I was just mentioning about user sign up, this is a complex workflow, which ideally should be a nested workflow, but still to demonstrate how you could use a combination of different type of flows. I've used this where it's if it's a user sign up and you would want to do multiple things. Say for example, you would want to create the user on DynamoDB, create the user on Cognito, and do some additional things with Event Bridge, all of it in parallel. The parallel option is available, which ensures there's a single point of start for all the executions, and all of them happen in parallel. If you would want to branch between different choices or based on some conditions, so say uh, if the you do a query and you get the response or the items response as 0, you know that there's no record available. So you want to ensure that, okay, if there's more records, probably proceed ahead with a different step, and if there's no records, just end the execution. So all these kind of choices are possible. So it makes it so easy for you to design your whole workflow such a way that you have choices. You could even wait for a while for X seconds and ensure, okay, I have made a HTTP call, and that HTTP call takes about say 30 seconds, and I have to wait until 30 seconds. So you could even wait for 30 seconds and then proceed ahead with your complete state machine execution. And when you're working with different array lists, the best thing that is available is maps, which helps you loops through each of the items, just like how we do it in the programmatical way with for each or the for loop. So when developers are building their own workflow, all these different operators that step functions provide makes it so easy for developers to create a complex workflow without even using their Lambda functions. So that's where I was just mentioning we'll head into the holistical view of going Lambda-less, right? Because step functions can enable you to create like for example, the whole thing on the screen where there's a user sign up process, and you would want to do multiple things in the traditional way of, or at least in the way where you're doing with serverless. You would have different events invoking Lambda functions, and that Lambda function would have different case conditions, and probably it would do SDK based calls to different AWS services. Or it could be even with posting different events to event pass, and from the event pass we take it forward. But the whole thing as a workflow that's using multiple different components could be integrated as a workflow itself with step functions. And the best part about it is step functions also supports error handling. So in case something goes wrong, you could even say, okay, for all the errors, probably catch it and complete the execution, or notify me with posting it to SNS or something like that. where you have a header handling condition available so that your state machine completes its execution and does not hang in the middle with an error, right? So it makes it so easy for mimicking a programmatic experience with a designer-based workflow system, which can create your whole workflow in just a bunch of clicks and also drag and drop. So I was just mentioning about intrinsic functions. So intrinsic functions, when I was just saying, it's those predefined functions which is available for you to pre-process and post-process. So earlier, about a month and a half before, step functions had only four intrinsic functions. That was working with arrays, string formats, and typecasting between JSON to string and string to JSON. But just a month and a half before, step functions introduced 14 different or 14 new intrinsic functions which work across arrays. It could be with JSONs, it could be with string. You could even generate a UUID. So in case you're creating a user and you want to create a new UUID, before you had to use a Lambda function because that's where your UUID package is available, and you could generate a UUID and create the user. Whereas in step functions itself, as an intrinsic function, you can generate a UUID, and this can even it be sent to a DynamoDB so that you don't have to even use your own user modules or node modules or anything such, any packages of your own where you have to define and provision for them in your Lambda function. And also working with different encodings. So you have some data that's coming in. Probably the best practices include when you're using Event Bridge or SNS or SQS, you tend to encode your data so that even if it's been intercepted for whatever reasons, it should not be, but even if it has been intercepted, users would have to decode it to get the actual original data, right? So step functions makes it so easy for you to encode and decode these data as intrinsic functions. So just imagine you have a huge base64 that's coming in. You again need a node package or a dependency packages that's needed to decode these. Whereas with step functions, you could just do it with an intrinsic call. So it makes it so easy for pre-processing and post-processing so that you can format the data the way how the specific service needs. So I have this in the further slides where my example or my demo walks through a creation of a record on DynamoDB, and we have a value that's coming in from a numeric value, but DynamoDB expects it to be as a string. So it expects the DynamoDB styled marshaled JSON where you have numeric and then the values in the string in form of a string. So when you have to typecast between a string integer into a string, it's hard. And that's where you could even use something where you could just format it as a string, the value that's coming in, and all of it is possible just with states.format, and you give the value from the service that you're getting as numeric, and add the double quotes so that it creates it into a string value. So all these hacks are possible, which makes it so easy for you to format the data the way how the specific service needs. Since it integrates with so many services, it's hard for developers to keep a track. Okay, DynamoDB requires it in this format, SQS requires it in this format, and for my event bridge, I require it in a specific format. And for converting these values to a specific format is so easy with these intrinsic functions. And the fact that step functions introduce 14 new intrinsic functions makes it so easy, so approachable for developers to just use these intrinsic function and create their own workflows. So I was just speaking about different service integrations. When you're integrating with different services, there are different patterns of integrating them. The traditional way of doing it is with request response, where you could see from the slide that there is a DynamoDB query that's happening, and when it's happening, it's using API actions in the background. It's doing a request, it waits for the response, and just typically how your HTTP calls are happening. It gets a response and returns back the response. So ideally, what happens is it's just mimicking the way how HTTP calls are happening, and these services are integrated so that it makes it so easy for developers to know, okay, I'm already using a Lambda function with which is invoking my DynamoDB, so I know the payload that DynamoDB requires. And with the same SDK way of SDK's payload structure, the similar thing could be used here, where you could define the whole thing, and it just does a HTTP call, request response call, so that it does the request, waits for the response, and returns back. And this request response is so fast that you wouldn't have to wait for a very long time. It's not like the traditional way of using with different REST APIs, where you have different timeouts, you have to wait for a long time. All this hassles is not there when you're doing with SDK based integrations. The other way is running it as a job, as a synchronous thing. So I was just mentioning earlier that you could even run a ECS task and wait for it to be executed, and then it proceeds ahead. And this could go up to 1 year, right? So what happens as runner's job is it creates a job and it runs in the background. When the job is running, the state machine execution is paused so that it waits until the job is executed. And once it has been executed, it comes back and says, okay, the job is complete, this response, and then it proceeds ahead with the state machine execution. So one thing that you can notice is that the resource in these a runner's job or a synchronous based integration is that it adds dot sync, or it prefixes or sorry suffixes dot sync for your resource type. So you could see the whole on for ECS run task, and it says dot sync, which means it's a runner's job type based off a service integration. The other way that's possible is with a callback. Of course, callbacks are something that most of us are familiar with, coming from the JavaScript world, because you have a function, you write a callback function, and whenever there's a response, it calls that function, so that whole execution proceeds. Similarly, what happens in step function based callbacks is that you define a token, and you send that token to a specific service. So in this example, I'm just sending the token to a Lambda function, and that token is being used in the Lambda function's execution. Once the Lambda function is being executed, that token is returned back to the step function. So what happens is that step function says, okay, this is the token. I'll wait until I get a token back, and then I'll proceed ahead. It's similar to how run as a job, but here it's waiting for the specific token to be returned for it to continue with the process of state machine execution. So that's how tokens could be sent. And when you're integrating with certain services like Lambda function, for example, you invoke the Lambda and you don't return the token back. It just pauses there, and it errors up telling, after a while, it errors up telling it's reached the maximum timeout, because it's expecting the token, but it didn't get the token. So it says this response is not intended for me and doesn't proceed ahead. And all of
Does it mean that it can be used for human interaction with the token? So basically, if you have let's say a task that let's say you would execute in a couple of days, not really now, you can use that token, which will basically hit the service and continue the step function when the certain person approves something or something like that.
Correct. So I was experimenting with one of the patterns where, based on the GitHub merge request that comes in, a PR when you raise it, until it's been approved, you don't want to proceed ahead with the state machine execution, right? So once it's been approved, it comes into with GitHub Actions and GitHub events. It comes into a Lambda function, and I'm storing this callback token in a DynamoDB table, so that I know for sure that this token is for this PR. Right. And when this has been approved, it sends that specific token back to Step Functions so that I could even use SNS to notify, hey, this PR has been merged. So
Right.
all of those things is possible.
So that's how the step functions can wait even up to 1 year, let's say.
Correct. Correct.
Yeah.
That's with standard. But with Express, the max it can go is 5 minutes.
Yeah. Yeah. True. True. Okay.
Yeah. So now the integration that happens with Step Function and different AWS services, there are two types. One is the optimized HTTP based, and the other is SDK based. Optimized HTTP based is limited to certain services only, and what it does is it uses a plain or a native HTTP call to do it. But in SDK, what happens is if you're familiar with the JavaScript SDK or the Boto 3 SDK that AWS provides, all these integrations are based on the same payload those specific services use in the SDK. So it makes it so easy. Like I was just mentioning, you know the payload, and you know what has to be done for to construct that payload to the specific service of that specific API action. Developers could easily create that payload and send it for the API action, and it executes. So when you're integrating with different services, like you just saw that there was a huge user sign up that I had added earlier in the slide, and all of it was available as one state machine itself, making that as in the world where we say infrastructure as code, that's the source of truth. Similarly, this workflow's source of truth is nothing but the state machine's ASL itself, which contains the whole workflow and the different flows it has, the different services it integrates. The complete flow itself is available as one source of truth. So all of these SDK-based integrations integrate directly with services, so you don't need an intermediate layer. In the traditional way, you would be using Lambda function because in the serverless, that's the go-to for all these intermediate pre-processing, post-processing, and integrating with different services. But now that we have SDK integrations, you can directly integrate with different services that AWS offers. Like, for example, you want to do a RDS query or execute a statement on RDS, you could directly do it with SDK integrations. You could even post your events to a specific event bus with direct integrations of SDK integrations. All of this, of course, like I was just mentioning, it goes into the world of Lambda-less, where you have less Lambda functions to manage, and your whole source of truth is your state machine itself, with different combinations of flows, intrinsic functions, all of it. Your complete workflow is managed without a Lambda function, because the traditional way of telling serverless workflow is that people expect to have a Lambda function in the background, right? In this case, you could go Lambda-less, which means that you're saving cost on your Lambda executions, and the way how the cost in terms of what your serverless workflow would be with Lambda functions versus the workflow on state machines itself is so cost optimized that you just have to worry about what type of workflow you're using and the different services that you're integrating, and be aware about the different API limits based pricing those services have. Because say, for example, you're doing it with DynamoDB, you know that, okay, for DynamoDB, for these many queries, I would have to pay so much. So you know ahead of time that DynamoDB pricing is this, and I have two, three tasks in my state machine, and when the task transition between those two, three states happen, that's when I would have to pay in case of a standard. And in case of an express, if that duration is very less, because if it's just 2, 3 tasks, it could just happen in a jiffy, right? When it's all integrating with different services, you just get the response from different servers. It goes to the next step, goes to the next step, and it completes the whole workflow in just a second. It could be in just a second, and sometimes could take more based on what the workflow is. Considering all these facts, a workflow on step functions is way more cheaper to run in terms of cost when compared with Lambda functions. So Of course, as serverless architects, we often try to optimize performance and optimize a cost that is included in the whole architecture, right? In this case, the performance also intact because there's no middle layer, and the cost is also reduced, making these workflows so performant and optimized. The different error handling that it supports with different state machines, okay, if this is the error, you can handle it. And knowing ahead of all these error, because you're so used to the whole SDK based integrations with Lambda functions, it makes it so easy for developers to predict, okay, this could come as an error. Say for example, uh, you don't have permissions, IAM permissions is not available, that could come as an error when integrating with a Lambda function. A Lambda function can time out after a certain time based on the configuration it holds. So all these error cases could be catched easily, and with step function and SDK integrations. It's so easy to predict these error cases because day in and day out, we as developers are using SDKs in our workflows itself, right? So it makes it so easy for developers to create those error handling techniques in your step functions, and all of the API actions that's available and the different flows that are there supports these error handling techniques so that it's easy for folks to just get started with their serverless workflow and create the whole workflow itself. And like I was just mentioning, last year, just before reInvent, around this time, Step Functions announced the support for 200 plus SDK integrations with different services. And that's been growing ever since. So recently, it's also about 150 plus SDK integrations with different API actions was announced. So for a fact that Step Functions will eventually support most of the services with most of the API actions, and the possibilities of creating your workflows is endless. And if you're thinking about a workflow that has different AIML services, you can integrate them with different step functions and SDK based integrations itself. Or even if, like I was just mentioning about the code build, right, where we have a PR from GitHub, all these things could be created as workflow, and it could even use some of the AWS services where, okay, I want to run test cases, or I want to ensure that my code is perfect. So you could use something like Code Guru or things like that to optimize your code, and with integration with those services itself natively on Step Functions. So the possibilities with Step Functions and SDK integrations is so much that the workflow that you think of in a serverless fashion is possible to build with Step Functions. So this is one screenshot that I got from Avengers Endgame, and you can see that I've highlighted Scotland, and the beauty of this is that Bruce Banner, who's the Hulk, uh, Thanos has wiped off 50% of the folks, and Bruce Banner is trying to keep a track of who were the victims of this blip. So you can see that when Scott Lang's face came up, the photo of Scott Lang came up, the name Scott Lang automatically comes up in the movie. And doing such a ML based search based on the person's face is so hard. And if you would want to do it with different celebrities, recognition provides the API action called as a recognize celebrity, and you can just send the photo of the celebrity and you get the name. This whole fact about how you can do it is so easy with AIML services, and if it's with regular folks like you and me, of course we would have to have our faces being trained by the AI model for it to recognize. But with celebrities, it's a lot easier, and we'll be looking into a workflow which is doing this, and in all the serverless fashion, using step functions, where we'll be using a photo which recognizes celebrities in the photo and adds them as records into DynamoDB. So when I was just mentioning about this workflow, the traditional way of looking at into it as a solution in terms of serverless is having different Lambda functions, which integrates with those specific uh, services itself. Of course, you could even have a monolith Lambda function which is doing this, but I'm a fan of keeping the Lambda function for its specific purpose. So you can see three different Lambda functions, which is one is integrating with recognition, one with DynamoDB, and the other for the other purposes, that whatever your workflow needs. So what happens here is that your Lambda function uses an event-based invocation. Could be from Event Bridge or S3 events itself, where there's a S3 event and you use that event to invoke the Lambda function. And the Lambda function uses that event and integrates with recognition, tries to get the celebrities in that image, and then again invokes another Lambda function to continue the process of putting all the celebrities into DynamoDB, and then invokes another Lambda function to proceed ahead with the execution. So if you think of this whole workflow, one thing that we could have done with step functions before the SDK integrations is that we could have considered having step functions with, again, three different Lambda functions doing the same job. But here it's coming as a workflow where, okay, you can have callbacks, or you could have different service integration patterns where, okay, unless I get the response from recognized celebrities Lambda function, I will not proceed ahead. So you can create the whole workflow based systems with Lambda function itself. This is just before SDK integrations, that was a year before, where your workflow again had Lambda functions doing the same things of integrating with different services. But the fact that Lambda function itself is not calling another Lambda function makes the whole event-driven architecture so beautiful with step functions, is that for a fact that even if some Lambda function fails, you can have error handling techniques to resolve them, or either say for a fact that, hey, this execution failed. So all of this with SDK integrations is just three of these tasks where you direct from the state machine execution, you directly invoke recognize celebrities SDK API action, and this uses the certain parameters like what's the bucket name, what's the S3 object. All of these parameters, you can just get it from the event, pass it to recognize, get the response back. And once you get the response back, you know that it's going to be a list of it's going to be an array list which has different JSON objects in it itself. So you could use something that is like a map which can loop through different objects, and you can get each of those objects and put it into DynamoDB. I've even used different intrinsic functions, like I was just mentioning about the UUID and the beauty of how you can generate a UUID from intrinsic function itself for your primary key, and also when you have to format the data, because you can see the match confidence. It's a value that usually comes in a floating based data type, and you have to use it as a string for DynamoDB. So you have to use something which does typecasting from floating to a string, and that's not possible, because you would have to ideally think of using Lambda functions again for all these typecasts. Where in this state machine and the intrinsic function that's available, you can format it as a string so that the value is converted into a string value, and you could just post it into DynamoDB as put object. And also, when you're working with different array items, you may want to get multiple array items, or for a fact, you just want to get one of it. In this case, what happens is recognizes the celebrity and gets their either their Wikipedia page or any of the publicly available page for that celebrity. So it could be one or it could be multiple. For a fact, we do know that it always returns one. So we can even take the first object, that is the object or the item in index 0. So getting an item from an array with index 0 is so easy with intrinsic function. You just have to mention the array itself and the index value that you want to get. So you can just get that object directly as a string and then pass it to DynamoDB. And when integrating with different API actions, I was just saying that You could be doing it with SDK actions. And so you can see that the API parameters that recognize needs is S3 object, which is bucket and the name of the object itself. And all of these details are coming in from the event. So you can just make sure it is from a parameter and define it as a parameter by adding dot dollar and the parameters name from the event so that you can resolve it, ensuring all these values are dynamic in nature, and so that you don't have to hard code something. Because when you're working, at least this is for S3, but when you're working with different services itself, you may have to pass a lot of data that's been sent from one task to another. One task meaning after processing one SDK integration with a specific API, with a specific AWS service, it has to proceed ahead with next. So you have to get the response from that. You probably have to get the response from the previous one or from the original event itself. And using all of these as parameters, it's so easy for folks to just say, okay, this is my parameter value. I can integrate it with this and define the path of the parameter so that it resolves the value and adds it when it's making the API call. So it's so easy when it's as templates, and creating them as parameters. All of these could be generic values, or even if, for example, if it's S3 and you're doing it on a development account, your production account S3 bucket name could be something else. And to define this or hard code this in the state machine itself could not it's not a good idea, because every time you're pushing it into production, you have to ensure that the S3 bucket name matches with the production one, and all of these hassles comes in. And when you're using infrastructure as code, all these could be some parameters that could be taken when using your CLI, or when the deploy is happening. So all of these as parameters makes it so easy for you to define them and add them as attributes into your state machine itself. So what you're seeing here is that the visual workflow editor provides us with a form-like experience where you can define this complete API payload or the API parameters, and it generates a JSON-based structure for the whole task. So you can see that I just had to fill out things like what's the parameters going to be like with the attributes from parameters itself. And uh, when I just switch a tab between the editor, it generates the whole JSON, and that JSON is available. So as ensuring the low code experience, you don't have to actually generate the whole JSON structure where you have to write the whole of these code. Whereas you just know the parameters, you can add them, and knowing what type of API action, it's so easy to generate this and create your own workflow experience. And when the next step is when with the DynamoDB, where you have to generate the value. Sorry, generate the value with the marshal JSON that DynamoDB offers. So creating such values with different step functions, provided intrinsic functions, is so easy that you can just mention it here in this value, where you can say this is a string and this value is going to be from an intrinsic function response, or the value that the intrinsic function returns, because it's going to be a UUID, and the UUID is going to come as a string. You know the value, and it's directly binded to the partition key of DynamoDB. So it's so easy for folks to just define these specific intrinsic functions. And again, with the whole idea of using the form-based attributes, adding or constructing the attributes, your whole JSON is available, and you can even see that since this is the last step, it even says the end is true, ensuring that okay, this after this there's no execution of the workflow. So we saw the workflow, what happens, and what this is about the complete architecture itself. Where if we do a S3 object put, and we have a way to invoke these step functions with event bridge. So we'll be using event bridge as the source of source for execution of these state machines. Whenever there's a put object, it sends it to event bus, and this event bus has a target for this specific state machine and invokes this whole workflow. This is also available as a GitHub repo. I've used a SAM-based application which is doing the whole thing. So this QR code takes you to the GitHub repo. You can even clone it, fork it, and deploy it on your own AWS account. So yep. So this is how the code looks in the GitHub repo, and it defines the template where I have a lot of things like it could be IAM roles, it could be my S3 bucket. All of these is provisioned in the template itself in the SAM app, and you can see here the whole state machine is defined, where it's saying, okay, this using definition from the state machine as a JSON, which I generated from the console, and I got the whole JSON file available, and I just added them here. So I can just reference this in my template so that it's just so easy for folks to create their infrastructure, that your state machine definition is available as a JSON file. You add them to your local code base and just reference them with the definition URL on your template, and it references to it when it's deploying. So again, when I'm doing all of these, my DynamoDB table is dynamic because this could be because I'm using one on the development account, one on a production account. So these values keep changing. And whenever these values keep changing, it could be the value from my from my template itself, from my infrastructure as code template itself. So I can just directly reference them and add them as definition substitutions in my state machine. And I could just say that this is the table value, and this has to be substituted in my IAC so that when the deploy happens from SAM, it uses the DynamoDB table's name from that specific resource and sends it into the state machine, and its value is being substituted. So again, going back to the fact that you don't have to hard code values, say for resource names, it's so easy with IAC-based step functions, where you can just reference them and add those values. And when you're working with different services, you would have to define the IAM permission that specific API action needs. And the fact with infrastructure as code is that you can even specify the policies. You can create your managed policies, customer managed policies, and add them up so that it's with the whole least privilege policy itself, you can just define the permission for the specific API action of that specific resource for this whole state machine to be executed. You can even see that event bridge event is being added, so that whenever there's a put object from S3, that is when this state machine gets executed. And this has been ensured with event bridge in the background. So whenever there's when there's a put object on S3, it creates an event and puts it into an event bus. From this event bus, we identify that this is the event and this is the target that's been set. And that target is nothing but invoking the state machine execution. So what we'll be doing now is I'll add an image on my S3 bucket. And once I add that, so I'm just adding a picture of Thor and Black Widow. So I'll just upload it. And when I upload it, a new state machine execution gets into a running state. And when I go there, you can see the complete workflow execution. And the experience on Step Functions console is so easy that you can even identify what's my start, what's my input going to be like, and the value that it holds So say for example, this is the event that this is the event bridge sends it into my state machine, and I'm using the object value from here to get the object's name and the bucket name from the detail. It uses that to do the recognize celebrities API action, and from that it gets the response with different celebrities, and it comes in as an array list. So that's where I was mentioning you use a map, and this map will do different iterations to ensure that we get the right responses. So here in this case, it identified two faces. So there are two objects. One is for Scarlett Johansson and Chris Hemsworth. So all of these is so easy that you could even see that I just put my object, honestly, it invoked my state function execution. And by the time we just went there, the whole execution was completed. So you can imagine the fact how fast this happens. That in the terms of Lambda functions, you might come into scenarios where you have your cold start. If in case the Lambda is not warm enough, you come into a cold start scenario where this could take time and the whole workflow could be delayed, or it could be lost, or even you may have to even retry. So all these hassles have been covered by step functions itself. So it's so easy for folks to just create a step function workflow and integrate them. And the console experience is so good that you can even say what's the resource type and what's the integration that's been started. It does the integration and gets a response back. And once the response has been fetched, it starts the map iteration, and you can see that it's using different iterations as a index object. It gets the value, does a DynamoDB put for one of the object, and then it does another put operation for the second celebrity that it recognized. And once this is all done, it exits the map state. And since this is the last state in the state machine itself, the whole state machine execution is completed. So this enables you to even, with step functions, it enables you to even share these events across with, you can just export the whole data, send it out, and test it out on a different account, and do things like that, where the console experience for debugging these workflows is so great. And just recently, Step Functions also announced support for Express workflows to have a debug option on the console, where you can even navigate across different values and view them out. So you can see that based on a number of iterations, you can even navigate to different iteration and see the value on the console. That's for the demo. Yep. So I've added the whole Jeff, just in case if we want to reiterate and you want to view, you want to view it as a table view on Step Function console, it's available. And I'm doing the same thing with a different image. So it recognized a couple of more celebrities, and all these celebrities were added into DynamoDB. So this is just a screenshot from DynamoDB to show that all these celebrities were added into the DynamoDB. So yep, that's about the whole workflow. And you could see that how in the whole workflow, I never used a single Lambda function. So again, going Lambda-less. So yeah.
Cool, great, thank you very much. Okay, let's now proceed with the questions. So guys, if you have some questions, there are 12 people currently watching the presentation. So guys, if you have some question, just ask. Guys and girls.
Yeah, and the whole presentation itself, in terms of why using a step function and SDK integration, is available as a blog post, and this QR code takes you to that blog post.
Okay, great.
Awesome. Thank you, Danny.
By the way, SQL Heisenberg is Jenan. Jenan is from community leader of AWS Bosnia and Herzegovina, Mostar, exactly.
Mhm.
And
Awesome.
he's also a hero.
Ah, awesome. So, Marin, have you used step functions or any questions that you have?
Yes, I'll come to that. I did use them, and I have few questions. I'm just waiting if somebody else will ask. But anyway, I'm going ahead. First of all, you clearly mentioned the differences between express and standard step function, but I'm not sure. Do both of them have a free tier option in pricing?
There is the number of executions that is there in terms of free tire.
Mm-hmm.
So in case if it's for experimental purpose, it definitely covers in the free tire version. But in case you're trying to develop a production level workflow, might cross the free tire is what I would say.
Okay.
But yes, it's part of the free tire.
Okay. Cool. Okay. Okay. I'm coming. I'm really fond of lambda-less, but I do have few concerns regarding that, because I kind of come to that world because I was trying at the time to integrate as much as possible with API gateway, with directly connecting to DynamoDB and different services. And I kind of when when you start working with it, it kind of looks very neat. It works very well, and I was very happy with it. But then, as the application grows, there is certain complexity that is basically now buried into your SEM or CloudFormation template. Doesn't matter, or Terraform. Never mind. And then it becomes a bit, from my opinion, a bit hard to manage. And
Yep. Yes, go on, go on, go on.
yeah, so I was having an issues. Let's say if I integrate with the DynamoDB and my queries got very complex, and now I need to basically manage that. It kind of gets complex to manage that in the same template. You understand what I'm trying to say?
Got it. So, in case you want to have multiple queries from different Dynamo tables, or it could be different GSIs that you're using, or different filter options that you're using in doing a query operation. So, at those times, yes, it becomes hard, and you might have to do multiple such queries. In with respect to API gateway, you might have to do multiple API gateway invocations and get those response and then consolidate. So at those times, yes, you have no other resort other than lambda functions, because that's great in terms of stitching things in together, right? So yeah.
But I think it's the best is to keep a kind of a balance between those two. Don't try to push as much as possible lambda-less, even if you see that it doesn't go. If there is a time for lambda-less, perfect, use lambda-less way of doing things. But in case you see that there is in the future complexity coming to certain function, then I think maybe it's a good time to switch to lambda. So I think that balanced way of integrating is the way to go. But I do really appreciate lambda-less approach and direct integrations.
Right.
Um,
So it all boils down to the question of what you're building and how you're building it, right?
mhm,
Because probably your use case needs a lot of complex queries, or it needs to validate different things, and doing it on a Lambda function is probably the best choice rather than doing it in as a
mm,
direct service integration. So
yeah.
yes, it all boils down to the use case and how you're solving it.
Mhm.
So yeah.
And you clearly defined into the step function definition that you have showed us um, how you actually can create a complex function
Mhm.
using few services in a very simple code. Um, and basically that would uh, that would probably take much more time when you need to, in let's say Lambda, when you need to, let's say import few libraries, few SDKs, then when you need to work with the actual code of those SDKs, that will really create um, actually it's going to be much more code than you have created for the case you have shown. Um, but on the other hand, direct integrations are coupling things way more, while having them in a lambdas are still in a decoupled, and that's the benefit of having them in lambdas. But again, it's a balanced. It needs to be balanced. But I also have two more concerns, and one is basically scalability. You have direct integrations between the services that scale differently. Let's say if you're using KMS,
Mhm.
and let's say KMS has a lower scalability than step function itself. In case you would need, if you would broke that scalability, that limit, you would get a throttling exception. So, and then you would need to error handle that in a step function, which kind of makes one situation that you don't want to be. So
Understood. Yeah.
yeah.
Yep.
So go ahead, please.
So yes, the very fact about lower limits is where I would say, because when you're doing direct integrations, you have to be aware about what that service is, what are the limitations it holds, and
Hmm.
KMS for that perfect example, right? Because the way KMS scales and the way how DynamoDB scales is way different, and even with DynamoDB, if you have certain constraints on read write capacities, it would be different. And if you define these configurations, probably it's good to do on a Lambda function because you know the way how it handles things. So
Hmm.
yeah.
Yeah, yeah. So read documentation and take care of scalability. You have, even you're doing serverless, you mind scalability also on serverless, and that's introduction for my new article that I'm writing about why do you need to think of scaling when you're doing serverless. It's gonna be
Awesome.
published soon.
Awesome. Look forward to
uh,
the blog post.
okay, cool, great. Um, yeah, and the one very a big issue with the direct integration, from my opinion, is automated testing. It kind of especially using AppSync with VTL, using API gateway with ETL, and now step function with its own definition becomes problematic for the people who are used on testing everything. I'm not the one, but there are some people. so, so
That
there are
said,
some people who are not really comfortable of not having automated tests everywhere.
so yeah, I mean, it's always good to test end to end on the cloud. And when you're doing these things, of course, I have seen folks write automation scripts, which is probably starting the execution with based on a API call, and like event bridge, using event bridge, posting events
Mhm.
to that, and starting
Yep.
the state machine execution. So all these with automation scripts is possible, just that it has to be done on the cloud and you
Yeah.
cannot do it anywhere else. So yeah.
Yeah. There is a local stack, but I don't think that it's the best way to do in that way. Basically, local stack is mimicking all the APIs of AWS pretty much in every service that you can imagine. But of course, it's not always up to date, but they're trying hard. But it's still something that the people are not recommending. But that's the closest that you can get for not testing the stuff on cloud, but testing it, let's say, locally. But if you want really to have a proper testing of those step functions, you will have to do it in cloud. There is no way around it.
Yep, because
yeah.
local testing is all mimicked with a specific input, or it could be events that a JSON event which has been used to mimic the whole process. And in your cloud, the event could be changed, or it could have some other value, and which might be a faulty execution. So it's always good to test on the cloud.
Okay, that's everything I had in mind to ask. Okay, now we are going to your questions to the public, and I'm excluded. Public needs to answer that. Otherwise, public is I'm not getting the voucher for what I have asked. So your guys will get the voucher of $25 from AWS. So you will basically be able to experiment a little bit on AWS cost. So Zach, you ask the questions, public is answering.
Awesome. So yeah, I spoke a lot about a specific integration type with step functions, and what's the other type of integration that's possible with these services. Probably you can put it on the chat and we'll have a winner. So I'll just repeat the question. There are two different service integrations that's possible on step functions. One is the SDK based. What's the other type?
Yeah, please put the answer into the chat in case you are the first one or only one. The first one gets the voucher.
Fastest fingers first. Okay, so I'll just repeat the question. There are two types of integrations with step functions. One is the SDK based integration, and what's the other type of integration?
Let's give you a few more seconds. Over Lambda.
You can integrate Lambda, but the way how you integrate Lambda is the answer. That's a hint.
So basically, honestly, I don't know the answer on this question. So I thought it was Lambda also. So basically, the integration is over SDK, and the other is integration over an API.
Yeah.
Or
yep. So when you go into integration type, there are two types. One is optimized, that is nothing but a optimized HTTP call itself, and the other is the SDK, that's the new one. Optimize.
Okay, right. Okay. Yeah, the optimize is actually the one that existed before that supported just few services.
Correct.
Okay, correct. Right. Okay. Anyway, Lambda is partially an answer, so Danny, you are the winner. Okay, Danny, I'm gonna send you the direct message with the key. So make sure you leave your mail below. Okay, we are going for another question.
Awesome. So I was mentioning about two types of integrations, where one runs for 1 year, which is the type of workflow that runs for 1 year. Oh, maximum allowed execution time is 1 year.
This is the easy one. Come on, guys. Tick, 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 tick. Then he says thank you.
Yep. Awesome.
Come on, people. This is the easy one.
Maybe we should have a countdown. Okay, so SQL Heisenberg is. I'll try. So in case if you're wondering what the question is, there's one specific type of workflow on step functions, which has a maximum execution time period of 1 year.
Yeah, one was 5 minutes standard.
Yep.
Okay, one
Awesome.
more. Okay, good. That's it. The standard was 1 year, and the express was 5 minutes only.
Yep.
With less abilities to debug. Yeah. Okay. Okay. So that's it. Basically, we have given 2 vouchers, and I will give them to the people that won. Perfect.
Awesome. So
anybody, anything that didn't ask but just came on her mind and wants to ask Jones before he leaves us to sleep, because it's 12:20 at his place.
yes.
Midnight, after midnight. Okay, Jones, we are not gonna keep you anymore. We're basically let you sleep. Thank you very much. This was a great presentation, and I personally loved it. And also we have some responses that it was fun. So it was fun, definitely. And thank you again. Hope we see you soon at some time with a different presentation, or at some of on the community day that you just shared on the chat. And in case you have something else to present in future, you're more than welcome to call me, and we're gonna manage and schedule something in the future.
Awesome. Yeah, thank you for hosting me, Milind. And I know this has been a short notice for the whole scheduling and the whole planning. So you did a wonderful job. Thank you for that. Thank you everybody
Thank you very
who's
much.
watching it. And
Okay, great. Good night, and
thank
see
you.
you. Bye
Good
bye.
evening. Bye bye. Good night.